Hey everybody, welcome to Bio 282 Lab Class Presentations. My name is Amir Temur, and the topic that I'm going to be talking about today is the breakdown of plastics using enzymes. The news article that I used is an article from CNN called Scientists Create Super Enzyme That Eats Plastic Bottles 6 times Faster. Before we talk about the article, I want to give you some background about PET. PET stands for polyethylene terephthalate. It is a very commonly used plastic because it is transparent, easy to recycle, shatterproof, and produces less waste compared to other plastics. Even though it has a lot of industrial benefits, it takes hundreds of years to decompose naturally. Plastic pollution is a global crisis today. Even if we recycle a lot of plastic, a large amount of the plastic ends up in oceans, and the already existing plastics is already there in the form of landfills and in oceans. Back in 2016, scientists found out a way of degrading these plastics at the rate of 4 weeks per plastic using an enzyme called PETase. PETase is found in green algae called Chlamydomonas reinhardti. CNN interviewed Dr. John McGeehan, the lead co-author and director for the Center of Enzyme Innovation at the University of Portsmouth. He was interviewed about a new super enzyme that can break down plastic 6 times faster than PETase. This new enzyme is created by linking the PETase enzyme with the MHETase enzyme. A mixture of the two breaks down PET twice as fast as PETase alone, and connecting the two enzymes by stitching their DNA together increases the speed another 3 times. This technique is commonly used in the biofuels industry to break down cellulases, but this is the first time that Dr. McGeehan had seen it in a similar approach used to break down plastics. The CNN article indicates that the full study has been published in a journal from the United States called the Proceedings of the National Academy of Sciences, or better known as PNAS. The study suggests that synthetic polymers were originally developed to avoid the use of animal-based products. However, the constant use and accumulation of plastics in the biosphere has become a global crisis. Among all those synthetic polymers that exist today, the most abundant is PET, which is made from TPA and EG. In response to that, microbes are evolving to break down these polymers into organic energy resources. So what does that do for the research at a large scale? Since we know a little bit about PET now, let's talk about MHETase now. Bioinformatics analysis suggests that MHETase evolves from ferulic acid esterases. There is a highly synergetic relationship between PETase and MHETase. The PETase enzyme is a cutinase-like serine hydrolase that attracts the PET polymer. PETase cleaves BHET, which is bis-hydroxyl terephthalate, into MHET, monohydroxyl terephthalate, which is further hydrolyzed by MHETase. There are some open-ended questions regarding the mobility of certain residues during the catalytic cycle of this process. Also, the fermentation of the MHETase enzyme is far less categorized compared to the PET, with only 2 published studies focused on its structure and engineering. Now let's compare the news article to the primary source. When we look at the news article, it is an extremely simplified version of the primary source. If you look at these 2 pictures, the CNN news article published this picture that shows the PETase enzyme being linked with the MHETase enzyme. The news article just tells you that the 2 enzymes have been linked together, while the picture on the right is from the results of the research from the primary resource, and it tells you the active sites that both the enzymes bind at and how their DNA is connected. I think the news article does a great job at simplifying the primary source, since a lot of the majority of the audience of CNN is not from a biological background. So it is easier for a general audience to understand what's going on with the plastic eating enzyme and how it functions. That being said, this is all from my side, and I'll leave you with the works cited page. If you have any questions, please feel free to ask me any questions.